Mysterious interstellar object produces light. Interstellar mystery deepens. Object 3I Atlas appears to generate its own light, challenging comet theory. A mysterious interstellar visitor racing through our solar system is leaving scientists puzzled. As new evidence suggests, it may be more than just a comet. According to Harvard astrophysicist Avi Loeb, the object known as 3I Atlas is producing a light in a way that differs conventional explanation. Unlike normal comets, which shine by reflecting sunlight off their dust and gas cloud, this object appears to generate its own glow, similar to a vehicle turning on its headlights. Now let's unpack the layers.
Welcome to the deep dive. Today, we're jumping into a real cosmic enigma that's got scientists seriously buzzing. We've gathered up the research, the articles, everything we could find on this interstellar object called 3I Atlas. Our mission here is to really unpack what makes this thing tick, what the latest insights are, and why it's just so baffling.
It really is a head-scratcher.
Yeah.
And what's so interesting, I think, is how it started. Initially, the consensus was, okay, it's a comet. A big one, sure, but still basically a comet. That was the standard view. But then, new observations started coming in, and the evidence just isn't lining up with that simple comet theory anymore. It's forcing a total rethink.
Right. So just to set the scene, originally it was thought to be this massive object, maybe 12 miles long, expected to make its closest pass by Earth around December 17th. Seemed pretty straightforward, if maybe unusually large. Was there anything weird right at the start, or did it really look like a standard, albeit interstellar, comet at first glance?
That's a good point. Initially, honestly, it looked pretty much like what you'd expect from a large comet coming in from interstellar space. The size was noted, yeah, but not completely out of the ordinary for these things. But then, this is where it gets really interesting. The core puzzle, the thing that changed the game, is its light. See, normal comets just reflect sunlight. That's how they shine. But 3I Atlas, it seems to be, generating its own light. Someone described it like a car turning on its headlights. That's not comet behavior.
Wow, turning on its headlights.
Yeah.
That's quite an image. And this wasn't just a guess, right? There was a key observation. I think it was the Hubble Space Telescope back on July 21st. What did that actually show? Because I read it wasn't like a laser beam or just an even glow either. It was described as an unusual emission of energy.
Exactly right. Hubble captured this image showing a concentrated spot of light, specifically on the side facing the sun. But like you said, not a sharp beam, not a uniform glow, just this unusual energy emission. And when Hubble data flags something as unusual, you pay attention. It's a strong indicator something unexpected is happening.
Okay, so an unusual emission, not just reflected sunlight. That brings us to Avi Loeb at Harvard, right? He's looked closely at this. What did he notice about the brightness specifically? Because that seemed to be a key piece contradicting the comet idea.
Yes, Loeb's observation on the brightness is critical. He pointed out that for a typical comet, the reflected light fades gradually as it moves further away. Makes sense, right? But 3I Atlas, its brightness drops off sharply. His analogy was perfect, more like a flashlight fading when you step away. That kind of sharp drop-off strongly implies the light source is internal. It's generating its own energy, not just passively reflecting the sun.
So if it's generating its own light, that opens up some pretty wild possibilities. What did Loeb suggest it could be? He's known for thinking outside the box, especially after Oumuamua.
Well, he definitely didn't hold back. Given that internal energy signature, he floated the possibility that 3I Atlas might actually be, and this is a quote, a spacecraft powered by nuclear energy. He even suggested that any dust seen might just be, stuff it picked up floating through interstellar space, not typical comet outgassing. But he was also very clear that this is speculation at this stage. We need much stronger evidence to confirm something that extraordinary.
A nuclear-powered spacecraft. Okay, that's definitely provocative. How does the wider scientific community react to that kind of idea? Is it seen as jumping the gun or a necessary exploration of possibilities when the standard model fails? What would count as stronger evidence?
Well, it's a mix, as you'd expect. There's huge interest, obviously, because the data is weird, but there's also a lot of scientific caution. Most astronomers want to exhaust every possible natural explanation first, however unlikely they seem. Stronger evidence. Things like getting a detailed spectrum of that light emission. Does it look artificial? Or maybe, an incredibly clear image showing non-natural shapes. Or even more bizarre behavior that just can't be explained naturally.
Yeah.
And adding to the puzzle, undermining that comet theory even more, is something else that's missing. The coma.
Ah, the coma. That's the big fuzzy cloud of gas and dust you usually see around a comet.
Exactly. As a comet nears the sun, the ice vaporizes, creating this cloud, and off the tail. It's the classic comet look. 3ITLS. It doesn't have one, just nothing there. And that's not a minor detail. It's fundamental. If it doesn't have a coma, calling it a comet becomes really, really difficult. It forces scientists to ask, okay, if it's not a comet, then what on Earth, or rather, what in space is it?
Okay, so no coma, and the light seems self-generated. That must change the estimates about its size too, right? If it's making its own light, it doesn't need to be as big to appear as bright as it does.
Precisely. If the light isn't just reflected sunlight off a huge surface, but generated internally, the object itself could be much smaller. Loeb, working with his colleague Eric Kito, crunched the numbers based on this idea. Their estimate, it might only be around 300 feet long, not 12 miles. That's a completely different beast.
300 feet instead of 12 miles. That's like expecting an aircraft carrier and finding a speedboat. Still fast, but fundamentally different.
It is. And interestingly, that 300-foot estimate puts it right in the same size category as Oumuamua. Remember Oumuamua, the first interstellar object detected back in 2017. And you'll recall Loeb has argued for years that Oumuamua wasn't natural either because it accelerated in ways gravity couldn't explain. So now we have potentially two interstellar visitors, similar in size, both showing highly unusual characteristics that defy easy natural explanation. You start to wonder.
Yeah, it does make you wonder if there's a pattern emerging. And speaking of unusual, let's talk about its path, its trajectory. I read that its path is considered highly unusual. It's going to swing near Venus, then Mars, then Jupiter. Loeb apparently calculated the odds of a natural object taking such a precise tour through the inner solar system. What were those odds?
Incredibly low, like less than 0.005%, vanishingly small. It's the kind of trajectory that if you were planning a gravitational slingshot tour of the planets, you might design.
Yeah.
For it to happen by chance with a random rock from interstellar space, the probability is just extraordinarily.
Less than 0.005%. That's where. So when you have this weird light, no coma, maybe a small size, and this incredibly unlikely path, scientists must have tried really hard to find some natural explanation that fits, right? What did they look at?
Oh, absolutely. That's the scientific process. You try to fit the observations into known physics first. They've considered things like maybe it's shedding weird ice particles we haven't seen before, or maybe it's debris from a specific type of stellar explosion. None quite match. Would it be a tiny black hole? Or emitting light from radioactive decay? Probably not, wouldn't generate enough light. What about friction? Maybe it's heating up by hitting interstellar gas. But space is just too empty for that to work effectively. And as we've said, normal comet activity, sublimation of ice, that just doesn't fit the light profile or the lack of a coma.
So it feels like they're running out of conventional options. Every natural explanation they test seems to fall short somewhere. That must be frustrating, but also kind of exciting because it pushes the boundaries.
It's exactly that. It's frustrating when things don't fit neatly, but that's often where the biggest discoveries happen. When you've exhausted the known possibilities, you're forced to consider the unknown, maybe even the extraordinary. That inability to find a simple natural fit is what really deepens the mystery here and keeps scientists looking closer.
So what is the next big step then? What are scientists looking forward to?
The big date circled on the calendar is October 3rd. That's when 3I is scheduled to make a relatively close pass by Mars. It's a really crucial opportunity for observation, maybe our best chance yet, to get a clearer look.
Okay, the Mars flyby. What are they hoping to get from that? Better pictures? Different kinds of data? What's the ultimate goal? To finally pin down if this is some weird natural thing or something else?
Both, really. They'll be throwing everything they can at it, hoping for much clearer images, yes. Also trying to get more detailed data on that light signature, its spectrum, any information about its composition or rotation. The hope is that this flyby will provide enough new information to decisively answer the question, is it a highly unusual but ultimately natural interstellar object? Or are we looking at evidence of technology from beyond our solar system? It's a huge moment.
Okay, so wrapping this up for now. 3I is this interstellar visitor that's just not playing by the usual rules. It seems to have its own light source. It's missing the standard comet coma. It might be much smaller than we first thought, and its path is incredibly unlikely. It really is one of the biggest head-scratchers in astronomy right now.
Absolutely. And it's a fantastic example of how science progresses. You have a theory, you get new data, and sometimes that data just smashes the old theory. It reminds us how much we don't know about the wider universe, about what might be drifting between the stars. It really encourages that critical thinking, that openness to reassessing everything when the evidence demands it.
So as 3i Anomalous continues its journey through our solar system, maybe near Mars soon, it leaves us with some huge questions. What else is out there? Could there be other objects like this? And if this is technology, what does that imply? It definitely gives you something to think about as we look up at the night sky. We'll certainly be watching for updates from that Mars flyby.
And you should too.
Okay, one question for you. Do you believe scientists are too quick to dismiss the possibility of extraterrestrial technology? Don't forget to comment it. Thanks.